Hello, my name is Matthew Tar, and today I want to demonstrate my networking assignment. I'll start by logging into one of the CSC machines. Alright, so basically, I'm just going to navigate to my code quickly. Alright, I'll first be running the program with a circuit network scheme and SHP protocol, with a transfer rate of 1 packet a second. Now I want to quickly demonstrate my code. So for the program, I have a graph class. I store each node into an array. Each edge is placed into a 2-dimensional dictionary, where the value of each edge is a tuple consisting of the weight, the propagation delay, max capacity, as well as the number of active connections on the edge. For the SHP protocol, I use Dijkstra's algorithm to calculate the shortest path between a start node and end node, and I return this path to the caller. For the LLP protocol, I couldn't use Dijkstra's algorithm, so I had to use a depth first search algorithm that was slightly modified. This allowed me to keep track of all the paths from the start node to the end node, and I can return the path of the least cost. So the program on the CSC machine finished running. There's the output at the end. Now I'll just run it with the SDP protocol. Alright, so moving on to the code, I also have a network class that contains a graph. I have a function called useLink, which consumes a resource on the link in the network. FreeLink does the opposite thing. Frees the link on a network. Route packet finds the shortest path between nodes A and B and returns the path. Reserve route takes in the path, calls useLink on each link in the path. Free route does the opposite thing and takes in the path and calls FreeLink on each link in the path. Alright, so it looks like the program on the CSC machine finished running. There's the output. Now I'll be running with the LLP protocol. Alright, so moving over the code with the main program, the main idea behind this was to use simulated time to create each connection. So I basically have 2 priority queues, one for the start times and one for the end times. I need these 2 data structures because I need to know when to start a connection and when to tear it down. So I start off by adding all the connection requests into the start times priority queue. I then declare my clock up here. I start at 0. I increment it by 0.001. With the inside the main while loop, I have another while loop which I take a connection request from the start times priority queue. I extract the start time. I check to see if it's equal to the clock. If it is, I try to start the connection. If the network class doesn't let me start the connection, I count it as a blocked packet, otherwise it's successful. If the start time is greater than the clock time, that means I can't start the connection just yet, so I just put it back in the priority queue to start later. Alright, with the second while loop, this is where I tear down any connections that I can. I pop a existing connection from the end times priority queue. I extract the end time. If the end time is equal to the clock, then I tear down the connection. If the end time is greater than the clock, however, then I simply put it back into the queue and tear the connection down later. If both queues are empty, then the program's finished. And finally, I print all the output at the end. And looks like the LLP protocol on the CSC machine finished running. There it is. And that's the end of my demonstration. Thank you.